The aerospace industry is now getting electrified at a very rapid pace, and one aircraft is shattering all existing speed records while setting new ones as well. This beast of an aircraft named Spirit of Innovation is Rolls-Royce's pioneering electric airplane and has officially become the world's fastest all-electric aircraft. But what more is there to this spectacular marvel of the aviation industry? Join us as we explore the aerospace industry's newest gem and the mystery that is the Spirit of Innovation. Propelled by a 400 kilowatt or a 500 horsepower electric powertrain and the most power-dense propulsion battery pack ever designed and assembled in the aerospace industry, the Spirit of Innovation is an aircraft unlike any other you've ever seen. And what's more remarkable, this phenomenal aircraft is already setting records on the global stage. In an experimental flight on November 16, 2021, the Spirit of Innovation broke all previous records in electric aircraft flight history to become the world's fastest all-electric aircraft. In its first test flight, the Spirit of Innovation reached an average speed of 556 kilometers per hour or 345 miles per hour as it traveled over a distance of 3 kilometers to squash the previous record set by Siemen's 330 LE aerobatic aircraft in 2017. This newborn beast of the skies developed by Rolls-Royce crushed Siemen's record by more than 213 kilometers per hour or 132 miles per hour. It also successfully climbed over 3,000 meters or about 10,000 feet in only 60 seconds. With this, it essentially hit another unprecedented milestone in the history of aviation, and following this string of maiden records, the Spirit of Innovation instantly put itself at the forefront of the race to accelerate the electrification of aircraft globally. You see, just while the aerospace industry was still basking in the euphoria of this giant leap in aerospace technology, this mystery of an aircraft would go right ahead to beat its own record and set another all-time high average speed for an electric aircraft. This time, it clocked 623 kilometers per hour, or just under 387 miles per hour. These trailblazing tests were both conducted at the Boscombe Down testing site, and these feats achieved by the Spirit of Innovation have since been officially confirmed by the World Air Transport Federation as unprecedented world records. Well, a quick clarification before we get things mixed up. So here's the thing. The Spirit of Innovation is being built by Rolls-Royce plc and not Rolls-Royce Motor Cars, the more popular subsidiary of the Rolls-Royce company. While Rolls-Royce Motor Cars is renowned for manufacturing some of the world's most luxurious cars, Rolls-Royce plc was established as a subsidiary of the business in 1971 and has since been focused on designing and manufacturing for civil aerospace as well as military aircraft and ships. Today, the brand boasts of more than 16,000 military engines that are actively in service, and it presently services the militaries of 103 nations of the world. Now back to our record-breaking aircraft. You see, the Spirit of Innovation, despite being Rolls-Royce's maiden all-electric aircraft, is partly funded by the UK's Airspace Technology Institute under a special project called ACCEL, Accelerating the Electrification of Flight. The reason for this was to ensure that the project strictly kept in line with its sole focus of developing cutting-edge technologies that will accelerate the all-around electrification of flights and the aerospace industry as a whole. But both Rolls-Royce and the UK's Airspace Institute would soon realize that they needed even more hands and expertise if truly they were poised on creating an all-electric that'll be revolutionary and would be a game-changer in the aviation industry. So, to ensure that they left no stone unturned, Rolls-Royce very early on in the project quickly reached a partnership agreement with a company called Electrified. While you might have never heard of this company before, it's actually one of the UK's leading and fast-rising aviation startups specializing in energy storage and the manufacturing of lightweight battery systems that are optimized for energy density. You see, the battery of an all-electric aircraft is its most important component, and with the Spirit of Innovation being Rolls-Royce's flagship project, it was of absolute importance that the aerospace giant got the battery design and component right. Again, an all-electric aircraft, especially one that was being designed to be as groundbreaking as the Spirit of Innovation, would also require modern and cutting-edge electric motors and controllers. To ensure that the very best motors and controllers were developed for its pioneering invention, Rolls-Royce also partnered with YASA Limited, the UK's leading manufacturer of electric motors and controllers. With the component team now fully assembled, Rolls-Royce quickly moved its attention to another grave challenge that had sprung up with the project. You see, every great invention in history always has a secret behind it, one that ultimately becomes the reason for its success. As for the spirit of innovation, one crucial piece of the puzzle was still missing, and this missing piece had now become Rolls-Royce's greatest obstacle. The company and its partners had a tough time deciding on how the airframe for the spirit of innovation should be designed, especially as the aircraft was to be like no other all-electric aircraft ever manufactured anywhere in the world. And while this challenge might appear like a common phenomenon with every revolutionary invention, this new challenge for the spirit of innovation was particularly peculiar. And while it might have seemed impossible to imagine, there was only one existing aircraft airframe that came close to being ideal for what was intended for the spirit of innovation, and even this airframe would still require sophisticated remodifications. The major confusion for the team developing the fastest all-electric aircraft ever was largely as regards where the most suitable location for the battery compartment would be. This was a major design issue that not even Rolls-Royce or any of its partners could quite wrap their heads around. But after much trial and error and a great deal of in-depth research, the team ultimately decided to model the design of the airframe for the spirit of innovation after the legendary Sharp Nemesis NXT, and this singular decision would mark a turning point in the aircraft's development. Here's the thing. The iconic Sharp Nemesis NXT was a record-breaking aircraft itself, and not only that, it was entirely designed and raced by the likewise legendary John Sharp. Designed in the US, the Nemesis NXT is a carbon fiber two-seat single-engine and low-wing aircraft with a retractable gear kit and was specifically designed for air racing. As such, it was powered by a highly tuned Lycoming TIO 540 NXT Thunderbolt 6-cylinder engine that produced around 400 horsepower. The Nemesis NXT had itself set a world record on July 30, 2008, after it cleared a 3-kilometer course at 573 kilometers per hour, or about 356 miles per hour. Only a year later, in September 2009, the Nemesis NXT broke its own earlier record, hitting 653 kilometers per hour, or about 406 miles per hour, and officially becoming the first home-built aircraft to exceed the 400 miles per hour average speed for aircraft racing. You see, the secret for the NXT's success was embedded in its airframe. The NXT's airframe was ahead of its time. It was a carbon fiber lightweight airframe that was greatly optimized for speed. Unlike other racing aircraft at the time, its thin NASA NLF wing carries no fuel, as the airframe was designed by Sharp himself to have a single 340-liter fuel tank in its fuselage and right over its main spar. Now, this was just ideal for an electric aircraft, making the NXT's powerful and sophisticated airframe the perfect choice for the spirit of innovation, an aircraft that was already being envisaged to be the future of electric aircraft. So, right after the decision was reached to model the NXT's airframe, Rolls-Royce had 2 Nemesis NXT airframes delivered to Electroflight in May 2018. The Lycoming engine was quickly replaced with a 400-kilowatt powertrain containing 6,480 cells in 3 combined battery packs as designed and developed by Electroflight. It also contained 3 high-power but low-speed 750R lightweight electric motors, all of which were fully designed and manufactured by YASA. A single multi-spline shaft can be slotted through all 3 motors thanks to the hollow female spline bearings that are included in each motor. The thin design of all 3 750R motors also made the powertrain extremely unique and powerful, making it capable of very high torque at a lower RPM. For context, while running at 750 V, this powertrain can easily deliver more than 530 horsepower at a lower RPM of 2200 and almost 1000 horsepower with each burst. This instantly made the Spirit of Innovation's powertrain a more superior design to the Nemesis NXT's previous combustion engine, further having a 90% energy efficiency rating. As a unit, the battery packs, motors, and control equipment all had the same weight as the existing power plant, but what was even more outstanding was that this fully electric system was now capable of generating up to 530 horsepower continuously. Now, with so much progress already made, and the greatest all-electric aircraft ever nearing completion, the team still had one final puzzle to figure out. There was still the tasking hurdle of ensuring that the Spirit of Innovation consistently had an even weight distribution all through its flight duration whenever it is airborne. To overcome this dilemma, the Cell team pulled off a redesign masterclass with the airframe of the Spirit of Innovation. They opted to compensate for the reduction in overall weight that regularly occurred with the Nemesis NXT as fuel levels dropped during flights by converting the airframe into a single-seater as against the double-seater of Sharp's original design. Now, this move did not only succeed in reducing the overall weight of the aircraft, but it also helped in moving the center of gravity slightly forward, with this becoming another important factor that has helped the Spirit of Innovation set the records that it did. Additionally, with the installed batteries having more weight and maintaining their weight all through the duration of flights, Rolls-Royce, for the first time in the development of all-electric aircraft, crafted the battery containment unit as a structural part of the Spirit of Innovation's airframe, thereby lowering the overall weight of the aircraft and further ensuring that it was fully optimized for speed. The team also installed 3 separate battery packs for each of the 3 motor trains. But here's what's more amazing. Each of these battery packs contains a maximum capacity of 18,650 Li ion cells, with each cell being connected by complex ultrasonic wire bonding that ensure that the motors get the maximum amount of current they need from the batteries with minimal resistance and almost no waste. Now, because these battery packs contain many power cells which all discharge energy at a very rapid rate, they produce an enormous amount of heat. This new challenge led the team behind the aircraft to develop a unique lightweight cooling system using a very innovative approach yet again. They put each battery pack in a fireproof container and lined it with Portuguese corks, which were to serve as a thermal barrier. To avoid overheating and ensure that all internal parts of the aircraft remain cool all through flights, 9 cooling fluid circuits and only 2 radiators were likewise built into the aircraft. While the Spirit of Innovation is undoubtedly the most remarkable achievement in the evolution of aerospace electrification to date, it'll appear that Rolls-Royce has its eyes set on an even higher goal than its newest groundbreaking achievement. Rolls-Royce is now looking into the development of electrical vertical takeoff and landing technologies that'll be used for high-speed air taxis over short and medium-range destinations.